All right, hello everyone. In this short introduction, I will talk about the role of CO2 transportation in CCS deployment. So first of all, I want to say sorry that actually this is not a slide that prepared for this meeting. So I lost my kind of access to my computer. So this is some old slides that I used before. All right, so yeah, so this map, I think I have two maps here. Just want to show the momentum of the carbon management. So the one at the top left are the CO2 related projects by September 2023 when Sarah Forbes based in LANL. So that time, so as you can tell, not as many projects we have right now. If you look at the maps at bottom right, there's over 200 projects in US right now. So that's actually just by March 2024. So now we have even more projects. I think recently we have another 23 carbon safe projects announced. So yeah, so you can see there's a lot of momentum on these carbon management projects. So in terms of CO2 transportation, it's always kind of a silent word when we talk about carbon capture and storage, or carbon capture, utilization, and storage, right? There's no transportation. However, this transportation is really critical if you want to facilitate large-scale CCS deployment. So how CO2 is transported? I think a lot of you guys are familiar with the transportation with pipelines, especially we have a lot of existing CO2 pipelines in the United States. Actually, we'll talk that later. So another common kind of transport mode, which is the truck, but that is more for the small scale or a small volume of CO2 transportation. And for the real transport, similar like a truck, it can just handle small volume of CO2 emissions. And in terms of the ship transportation, if the CO2 storage formation is offshore, right, ship is another kind of transportation mode. So in order to facilitate large-scale CCS deployment in the coming decades, I believe that CO2 pipeline transportation mode is still going to be the most common method for transportation. And before look at the CO2 pipeline outlook in maybe 20, 30 years, right? Let's first look at the existing CO2 pipelines in the United States. I think Bob already touched a little bit on the existing pipelines in the Permian region. So yeah, so currently we have over 5,500 miles of existing CO2 pipelines. So these pipelines are actually mainly for enhanced oil recovery. And they are kind of located in three major regions. One of them is actually linking the natural CO2 dome from Colorado towards the Permian Basin. And yeah, so yeah, the bottom left, the blue lines, the famous Cortez pipeline operated by Kinder Morgan. And we also have a lot of existing pipelines in Rocky Mountain region, mainly in Wyoming. And also we have a lot of existing pipelines in the Gulf Coast region. So these are the existing pipelines, and we have talked the net zero emissions a lot, right? So then how many miles of new pipelines will be needed to achieve this net zero emission target by 2050? If you just look at this amount of CO2 sources or emitters here. So in Secretary talk, so she already talked about this famous case study by Princeton University in the Net Zero America project. So they have done a case study, try to figure out what will be the required pipeline in the United States to meet the net zero target. So the figure on the map on the left-hand side basically shows the required pipeline by 2030. As you can tell that over 11.8 thousand miles of new pipelines will be needed in order to transfer about 65 million metric tons CO2 per year. And by 2050, if we look at about 1 gigaton CO2 storage at that level, so we need about 65.8 thousand miles of new pipelines. So this is a lot of pipelines. And actually for Nano, we also did a similar kind of case study for the Office of Forest Energy and Carbon Management. So for this national scale CCS pipeline modeling work, the object here is to utilize a tool called CESAM to understand the potential national scale CCS infrastructure deployment scenarios. So here the CESAM is a tool developed by LANL and has been developed over a decade and currently has been widely utilized in a lot of other large-scale CCS transport level modeling or even commercial scale projects, for example, carbon safe. So for this particular work is in coordination with IVCM office and collaboration with the location team. We have run a lot of different case studies. So the one that I'm going to here is called Net Zero Inflation Reduction Act case. And so this map basically shows the CO2 sources that we have looked at. And basically the emissions that we consider are from 5 different sectors. And the major kind of emissions are from the power sectors, which is indicated by the blue circles in this map. And also we have the emissions from cement plant, which is indicated by the light blue colors. And also we looked at the natural gas processing facilities. And also we have the hydrogen plants that are being considered in this study. So for this hydrogen power plants, actually not just existing hydrogen plants, we also have a kind of projection of the potential hydrogen plants based on the hydrogen market, those kind of models. So for this case study, we look at in total 952 different point source. And also we considered direct air capture and those kind of technology starting from 2033 or 34, sorry about that. And before we kind of do the pipeline network modeling, we need to kind of find a home for the CO2. So this map basically shows the feasible CO2 storage formations. So this kind of data set actually is based on the NETL, the National Energy Technology Laboratory's NetCop database. So if you look at this map, we have estimated the storage resources and the associated storage cost for the lower 48 states. And as you can tell, there's a lot of storage resources along the Gulf Coast and also in the Mountain West region, and also in the California state. So in terms of the storage cost, so in this map, the rod, right, the different color corresponding to different storage cost. The red color corresponding to much higher cost, over $100 per ton of CO2 stored, and the blue color corresponding to storage cost less than $5. So let's say if we look at the potential storage formations in New Mexico, so we do have quite a few kind of feasible formations for CO2 storage, especially in the San Juan Basin, that area, northwestern, right, of New Mexico, and also we have storage resources located in Permian Basin, New Mexico side Permian Basin. So after we have a good understanding of the CO2 source and the home for the CO2 storage, then we apply the same CCS tool to figure out what will be the optimal connectivity in terms of the CO2 source and the storage formation, those kind of matching. So this is the projection in terms of CO2 pipelines by 2050. As you can see here, there's going to be a lot of CO2 pipelines required in the Midwest region and also along the Gulf Coast. So if you look at in the Mountain West region, especially in New Mexico, so we do have quite a few sources over there, right? And the San Juan Basin is kind of the best place for the CO2 storage in New Mexico itself. So I will stop here, and I will take probably some question later after this.